Our next stop brings us to one of the most iconic cities in the world, Paris. Adam and Liam have planned a trip across Europe and will begin their journey in France. Both of them have booked flights from New York to Paris, but are on different planes. Adam's plane left earlier and has already covered a distance of 200 miles. His plane travels at a constant speed of 400 miles an hour. Liam's plane left later, so he's only covered a distance of 50 miles. But Liam's plane is flying at a constant speed of 500 miles an hour. How long will it take Liam's plane to catch up to Adam's? The first step when solving any system is writing two equations that have two variables in them. If you're confused with where to start, think about what the question wants us to solve for, because that will almost always be a variable. In this problem, we have to solve for time, since it wants us to find how long it'll take Liam to catch up to Adam. Since we are already dealing with units like miles per hour, let's use h to represent time in hours. Now let's look at all the places where it tells us about time. A key concept exams like to test students on is the relationship between speed, time, and distance. Luckily, this relationship is very easy to remember. It's simply d equals rt, which stands for distance equals rate times time. The question tells us that Adam's plane flies at 400 miles an hour. So to calculate the distance traveled, we can multiply 400, which is the rate, times h, which represents time. That's because distance equals rate times time, and rate is the same thing as speed. And since we know that this solves for distance, our second variable must represent distance. Let's call distance d. So for Adam, we have the equation d equals 400h to represent the distance his plane travels. But we're not done yet, because the question tells us that Adam has already covered a distance of 200 miles. So to account for that, we simply add 200 to our equation. This gives us d equals 400h plus 200. Notice that this format resembles slope-intercept form, where the slope is 400 and the y-intercept is 200, which makes sense since slope is always a rate of change, and the y-intercept in this case represents the 200-mile head start. Now let's write an equation for Liam. Our problem says that Liam's plane flies at a speed of 500 miles an hour. So if we multiply 500, the rate, times h, which is the time, we'll get the distance that his plane travels. So the equation becomes d equals 500h. The question also tells us that Liam's plane has already covered a distance of 50 miles, so we add 50 to our equation. This gives us d equals 500h plus 50. Now we have a system of equations that represents this situation. Substitution works best in a situation like this, where you have two equations that solve for the same variable. When you have something like this, you can sub out the d in the first equation with 500h plus 50, because the second equation tells us that d equals 500h plus 50. This makes sense too, because we are trying to find how long it'll take Liam's plane to catch up to Adam's, which only happens when both planes will have covered the same distance. So we set both equations that solve for the distance equal to each other. This gives us 500h plus 50 equals 400h plus 200. Now we simply solve this like we would any regular equation. We first have to get our constants on one side and our variables on the other. So let's subtract both sides by 400h. This gives us 100h plus 50 equals 200. Now we can subtract 50 from both sides. This leaves us with 100h equals 150. We then can divide both sides by 100 to isolate the h. This gives us h equals 1.5. So it'll take only 1.5 hours for Liam's plane to catch up to Adam's.